Welcome to Newsbeacon, your trusted source for breaking headlines, global insights, and sharp analysis from around the world. If you're new here, don't forget to hit that subscribe button and turn on notifications so you never miss an update. In the silent theater of the cosmos, a new actor appeared, 3I Atlas. In the summer of 2025, as it neared our solar system, it flared with a sudden, brilliant glow, what some called a nuclear pulse. This was no ordinary comet. Was it a beacon, a warning, or the exhaust of an alien engine? The questions ignited debate worldwide. A pulse, in human terms, is a sign of life or a signal. Was this a message or a cosmic accident? The event transformed 3I Atlas from a curiosity into a scientific obsession. Was this a natural phenomenon, or the signature of alien technology? The universe had thrown down a challenge, and humanity was ready to investigate. Our solar system is not isolated. It's a harbor where interstellar objects sometimes drift in. These cosmic wanderers born in distant star systems travel for millions, sometimes billions of years before crossing our path. Their journeys are shaped by the gravitational dance of stars and planets, and when they finally arrive, they bring with them stories from the farthest reaches of the galaxy. For most of history, we thought everything in our sky belonged to our sun, until Oumuamua arrived in 2017, a messenger from afar. Its discovery was a turning point, a moment that challenged our assumptions about what could visit our cosmic neighborhood. Astronomers around the world scrambled to observe it, realizing that we were witnessing something truly unprecedented. Its odd, cigar-like shape and mysterious acceleration sparked wild theories. Was it a natural fragment, or could it be something artificial, perhaps even a probe from another civilization? The debate raged in scientific circles and captured the imagination of the public, highlighting just how little we know about what lies beyond our solar system. Then came 2I Borisov in 2019, a more familiar comet proving that interstellar comets exist. Unlike Oumuamua, Borisov looked and behaved like the comets we know, but its interstellar origin was unmistakable. It was a cosmic confirmation that our solar system is not unique in receiving visitors from the stars. These encounters taught us the galaxy is dynamic, with material exchanged between stars. Star systems are not closed boxes. They share and swap debris, comets, and asteroids, creating a vast, interconnected web of cosmic material. This exchange may even play a role in spreading the ingredients for life across the galaxy. Each interstellar object is a time capsule carrying secrets from its birthplace. Locked within their icy cores and rocky shells are clues about the conditions and chemistry of other solar systems, preserved for eons as they journey through the void. By studying them, we learn about the building blocks of distant worlds. Every fragment, every dust grain is a piece of a much larger puzzle, one that could reveal how planets form, how water and organics travel through space, and perhaps even how life begins. So when 3I Atlas appeared, it was more than just another rock. It was the next chapter in our cosmic exploration. Each new interstellar object is a rare opportunity, a fleeting chance to catch a glimpse of the unknown and expand the boundaries of our knowledge. We became galactic archaeologists, piecing together the story of our place in the universe. With every observation, every data point, we reconstruct the history of these visitors and in turn, the history of our own solar system. Oumuamua was the enigma, Borisov the confirmation, and 3I Atlas promised revelation. Each one is a milestone, marking our progress in understanding the galaxy's hidden connections and the mysteries that still await us. Each visitor is a new clue, a chance to test our theories and expand our understanding. The more we discover, the more questions arise, driving us to look deeper and reach farther into the cosmos. The saga of interstellar objects is just beginning. With new telescopes and technology, we are poised to catch more of these travelers, each one offering a fresh perspective on the universe's grand design. With 3I Atlas, the stakes and the mysteries were higher than ever. As we await the next visitor, we stand ready to unlock more secrets from the stars, knowing that each discovery brings us closer to understanding our place in the cosmic story. The story of 3I Atlas begins on a crisp, clear night in Chile, where the Atlas telescope scanned the heavens for anything unusual. Among the countless stars and drifting asteroids, it detected something truly extraordinary, a faint, fast-moving object, unlike anything astronomers had seen before. This was the first time the world would hear of 3I Atlas, a visitor from the depths of interstellar space. The object's path through our solar system was hyperbolic, a mathematical signature that proved it wasn't bound to the sun. It was just passing through, on a one-way journey from the unknown, hinting at origins far beyond the familiar planets and comets of our own system. At first, astronomers were stunned by its apparent size. Early calculations suggested it could be as much as 20 kilometers across, an object so large it would dwarf most known comets and asteroids. The idea of such a massive interstellar traveler was both thrilling and a little unsettling. News of the discovery spread quickly, sparking excitement and debate in observatories around the world. What was this giant, and what secrets did it carry from the distant reaches of the galaxy? As more powerful telescopes turned their gaze toward the object, the story began to shift. New data poured in, challenging those first bold estimates and forcing astronomers to rethink what they thought they knew. The Hubble Space Telescope, with its unmatched clarity, revealed a crucial detail. The brilliant glow surrounding 3.1 Atlas wasn't coming from a solid rocky surface. Instead, it was a vast, shimmering cloud of gas and dust, enveloping a much smaller core hidden deep within. The true nucleus, it turned out, was only a few hundred meters to a few kilometers wide, a tiny, ghostly fragment compared to the enormous cloud it carried. The object's real size was a fraction of what was first imagined. Yet despite its small core, 3.1 Atlas shone with an intensity that defied expectations. Its brightness was far greater than what its size alone could explain, leaving astronomers puzzled. Something was happening on or around the nucleus, something dynamic. The light wasn't just reflected sunlight, it was the result of a process, a transformation taking place as the object raced through the inner solar system. The object was alive with activity, spewing jets of gas and dust into space. This outgassing created a massive reflective shroud, a glowing coma that made the object appear much larger and brighter than it really was. This confusion between the apparent size and the actual size of the nucleus was the first major clue that 3.1 Atlas was no ordinary visitor. It was a puzzle, wrapped in a cloud of mystery. 3.1 Atlas was not just a chunk of inert rock drifting through space. It was a living mystery, a cosmic ghost that challenged our understanding and demanded closer scrutiny. The ghost in the telescope beckoned us onward, inviting astronomers and dreamers alike to unravel its secrets and discover what stories it might tell from the far side of the stars. As 3.1 Atlas approached our solar system, astronomers around the world watched with growing fascination. Its behavior grew stranger with every new observation, defying expectations and challenging our understanding of how objects from deep space should act. Most comets display a tail that streams behind them, created by sunlight pushing dust and gas away from the nucleus. But this object was different. Its glow was concentrated ahead of the nucleus, ahead, not behind, completely defying the basic laws of cometary physics and leaving scientists puzzled. This bizarre phenomenon led Harvard astrophysicist Dr. Avi Loeb to propose a radical idea. What if this wasn't a natural object at all? Could it be an alien probe, powered by a nuclear reactor or some other advanced technology, sent intentionally from another civilization? The forward-facing glow, he argued, might be energy leakage from a propulsion system, or perhaps a deliberate pulse from an alien engine designed to push the craft through interstellar space. Such a mechanism would be unlike anything humans have ever built or even imagined. The theory electrified the scientific community. Suddenly, the object was no longer just a curiosity. It was a potential breakthrough, a chance to glimpse technology far beyond our own. Was this a machine, not a rock? Could we be witnessing the first evidence of extraterrestrial engineering drifting silently through the void? Loeb urged open-mindedness. He reminded his colleagues that extraordinary claims require extraordinary evidence, but that such possibilities shouldn't be dismissed outright simply because they seem improbable. The debate wasn't just about power sources or propulsion, it was about intent, about the motivations of a possible alien intelligence. Was this object a probe, a relic, or something else entirely? If artificial, who built it and why? Was it a message, a scout, or simply cosmic debris from a distant civilization's past? The alien technology hypothesis forced us to confront profound questions about our place in the universe. Are we truly alone? Or is the cosmos teeming with life and intelligence waiting to be discovered? 3.1 Atlas became more than a comet. It was a potential messenger from the stars. A silent envoy carrying secrets from beyond our solar system. The debate shifted from astrophysics to existential wonder as humanity looked up and asked, what else might be out there waiting to be found? Faced with a cosmic enigma, the world's observatories mobilized. Hubble helped resolve the object's true size, peering through the haze. Tests, designed to find exoplanets, had already captured data showing 3I Atlas was bright and active far from the Sun. The James Webb Space Telescope, with its powerful infrared vision, was poised to analyze the object's chemical makeup. Each new dataset was a page in a cosmic detective story. Would the evidence reveal alien technology or natural chemistry? The eyes of humanity were fixed on 3I Atlas, awaiting the truth. Data from the James Webb Space Telescope brought clarity. The NIR-SPEC instrument revealed a spectrum dominated by carbon dioxide, a smoking gun for a natural comet. Carbon dioxide ice sublimates at low temperatures, explaining the object's intense activity far from the Sun. The forward-facing glow was a massive cloud of gas, not an engine's pulse. Further analysis found water vapor and carbon monoxide, common comet ingredients. Unusually, up to 20% of the surface was active, much higher than typical comets. 3I Atlas was a fountain of volatile ices, not a machine. Its chemistry offered a glimpse into the conditions of its home system. The evidence pointed away from science fiction toward a wondrous scientific truth. The investigation became a case study in scientific process. On one side, Dr. Loeb's bold alien technology hypothesis, urging openness to the extraordinary. On the other, the broader community, led by scientists like Tony Santana Rose, who argued for a natural explanation, volatile ices, not alien engines. The tension wasn't conflict, but healthy skepticism. The alien tech theory pushed astronomers to gather the best data and rigorously test every idea. In the end, the evidence was clear. The glow was from carbon dioxide sublimation, not technology. The story of 3I Atlas showed the value of imagination, but the necessity of evidence. Science thrives on both wild ideas and careful analysis. The debate was about the disciplined search for truth. 3I Atlas became a lesson in how science works. After months of study, the verdict was clear. 3I Atlas is not an alien spacecraft. It's a natural interstellar comet, its brilliance caused by outgassing carbon dioxide as it neared the Sun. This high CO2 content makes it special, a chemical snapshot of a distant planetary nursery. It survived its solar encounter and now drifts back into interstellar space, never to return. The conclusion is a triumph of the scientific method. We considered all possibilities, followed the evidence, and solved the mystery. 3I Atlas reminds us that the universe's wonders are often more subtle and more fascinating than fiction. The saga of 3I Atlas is a lesson in curiosity and humility. The universe doesn't exist to fulfill our hopes, it simply is. Science's purpose is to understand, not to confirm our desires. The search for knowledge is endless. Every discovery, natural or not, is valuable. Speculation about alien technology sparked debate and pushed science forward. With better telescopes, we'll find more interstellar visitors, each a new messenger, each a new mystery. The adventure of science is in questioning, exploring, and seeing the universe with fresh eyes. The voyage is endless, and it has just begun.